You are a professional robber planning to rob houses along a street. Each house has a certain amount of money stashed. The only constraint stopping you from robbing each of them is that the adjacent houses have security systems connected, and it will automatically contact the police if two adjacent houses were broken into on the same night. Given an integer of array nums representing the amount of money of each house, return the maximum amount of money you could rob tonight without alerting the police. So this right here is our second example, and let's talk about how we would rob these houses. So moving from left to right, we would say let's pick the first house, the third house, and the fifth house. We have to skip the 7 and the 3 because if we're going in this way, we can't pick adjacent houses. So if we were to rob these houses, we'd get 13. And if we decided to rob the 7 and the 3 house, we'd get 10. So looking at this, it looks like our solution is just to alternate houses. And at least for me, this doesn't seem like the right idea. So let's try to come up with a different example to see if we can break this pattern. So let's just move this out of the way so we can have some more room for ourselves. And let's try to make an example where we would not do just alternating houses. And I think there's an easy way of just doing that to begin with. So let's just say like 2, 10, 2, 2, 10. And I think you can see where I'm going with this right now. I'm just going to add a couple of numbers just for later examples that we're going to be going over. So again, moving from left to right, robbing the houses, we can see that we want to take this 10, and if we try to mess around with these ones, we might not be able to get this 10. So we know that we can, if we rob this house for the 10, we can't get this one, so this one's out. But if we rob this one as well, we're not able to get the 10. So in this case, what we're just going to do is we're going to skip both of these houses and go right for this 10 to get that 20 value. And then we can continue on getting this 4, ignoring the 3 because it's next to this house. So cool, we came up with another case that we don't have to just completely alternate houses. We came up with something where we get to skip 2 houses at a time. But what about 3? Are we able to skip 3 houses at a time? And the answer for that is going to be no. Let's say, for example, we had a 10 right here as well. It's unnecessary because we could just take this house, skip this house, take this house, skip this house. So if we were to skip 3 houses, it is certainly the case that we're always going to be missing out on money. And you might be asking yourself, all right, this is great and all. We're starting to get the beginnings of our algorithm, but what is the data structure that we're working on? So as we were going through our examples, we've been marking down which houses that we have been robbing from. So instead of just doing it for what we can see to be our maximum case, let's do it for all cases instead. And what do I mean by that? Let's say we're moving from left to right, stealing from houses again, and we come to a house. What's the maximum number that we can get from this? 10. When we get to the next house, it can only be 2. And why is that? It's because we're not able to rob the house next to us. So just for this case, it's going to be 2. We go again, and this one is going to be 12, just because we're able to skip this house and go here. And then for this one, we know it's going to be 20, because we had done that example before. This is the case where we skip 2 different houses. So now this is where it gets a little more interesting. When we get here, we know we have to skip this house. And we can either skip this one or this one. But up to this point, we might not be able to recognize how much we've actually stolen. But we can use this array that we've been keeping track of what values we've been stealing from to say, what's our new answer? In this case, we're just going to look at like the maximum of these 2, because again, we skip this house, we skip this house, and we can say this number is 15. This again is just another dynamic programming problem. So let's continue with the rest of this. We get up to here, we have to skip this house, and we know that this one's the right one, but let's do our example again. We want to consider these 2 houses. Why? Because we're able to skip either 1 house or 2 houses. In this case, we know that up until this point, our maximum number had been 20. So in this case, our answer is going to be 24. Lastly, we need to mention that either this one or this one can be our final answer. And why is that? Because for our second to last house, we know that we're not going to be including this one or this one. But what if this number was maybe like 100 or 1,000 or anything really, really large? It would mean that this one would be much larger as well. So for our final answer, we need to make sure that we're checking either the second to last one or the last one in our dynamic programming approach. All right, this is looking good. We have our algorithm and our data structure. Let's code this up. All right, so let's first start off with making our data structure. So dp equals default dict. You can use an array like how we did in our picture example, but I encourage you to use a default dict because it does the same thing except more, and I'll be using this a lot throughout all of our questions that we take on. So let's start building up our data structure from the bottom up. So normally with this, we usually start off with base cases and then build our way up, but I'm going to take the opposite approach just for clarity, and you'll see what I mean in just a minute. So building up our dynamic programming data structure, we're going to say for I in range len nums. Whenever we come to a new house, dp I, we're going to take the value of that house, nums I, and then we're going to add the maximum value of whatever's 2 before us or 3 before us. So we want to say max dp, because we need to look at the answers that we have already solved. So dp I minus 2 or dp I minus 3. So looking at this, we have a range of 0 to nums, but because we have I minus 2 and I minus 3, that just means that we have to have a range from 3 to our numbers. And now let's work on those base cases. We want to have at least from 0 to 3 covered, so we're able to do this iterative step. So we are going to say dp of 0 equals nums of 0, dp of 1 equals nums of 1, and dp of 2 is going to be nums of 0 plus nums of 2. And why is this one different? It's just because we know that all of our numbers are non-negative, so we're always going to include this second house to say we're guaranteed to either have a greater value or equal value when we include more houses because it is non-negative. And great, we finally have all of our base cases to build up our dynamic programming array. But we still need to include some edge cases as well, just the 0 to 2 cases. Because if we have anything less than 3, we would still crash our program. So we want to say if len nums equals 1, return nums of 0. If we have one house, just return that value for the house. If we have 2 houses, return the max of either the first house or the second house. And if we have 3 houses, we want to say return either the sum of the first and the third house, the first and the third house, or the second house. And finally, we just want to say return the max of dp len nums minus 1. So getting either the last element or the second to last element in our dp array. Forget the s. All right, everything looks good. Submit. And there we go. A link for the code will be in the description. And if you like this video, please like, subscribe. It really, really helps grow out the channel. Thanks.